In this lesson, we are going to learn about AnalogWrite, where we will send PWM or pulse width modulation to the pen, where we can connect a motor to control the speed of motor, or an LED where we can change the intensity of brightness of an LED, or for any other purpose. First, we are going to do simple fade, then we are going to do fade and steps using for loop, and then we learn about for loop. After that, we are learning about while loop, and then we will learn do while loop. This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Welcome to Arduino course by Robojax. In this lesson, we are going to use Arduino's AnalogWrite to write analog signal to the pen. So AnalogWrite is to send pulse width modulation PWM signal to a pen to control, for example, the speed of a motor, or to control the brightness of an LED or other applications. This is a digital signal. We have 0 volts and then 5. We call the 0 as a low and the high as 5 volts, and it goes down. So this portion is on and this portion is off. The same way, this is high, high, and these are high, as you can see, and these portions are low. Now we want to control the time that it turns on and it turns off this portion. Now let's see, this is a 20% duty cycle, which means 20% of the time it is high and 80% or 4 times it is low, and this is 60%, so the high time is longer or longer period and the low is less, and duty cycle is 20% and 60%. Here this is 50%, the high and low are equal, and this is again 20%, you can see it like that. And if you look here, 10, 30 and 50%, this is the time that it is high, that's 10% or 30%, something like this, and 50% looks like this of duty cycle in pulse width modulation. And 60% duty cycle means 3/5 of a signal, and 20% is 1/5 of the signal, 100% is full signal. For example, if we have 5 volts continuously, this could be 100% duty cycle. Or if you have 5 volt system, if you set the pen to 100%, you will get continuously 5 volts. Now, to control a pen and send pulse width modulation signal, we use digital write, and it has 2 parameters with a comma separated. The first one is a value, which is from 0 to 255, so this cannot accept anything outside this number. And then the pen is the Arduino pen that you are assigning or writing the signal to. So the value would be between 0 to 255, and where does that come from? It is 2 to the power 8 minus 1 is 255, because this is an 8-bit system. So 2 to the power 8 is 255. And if you want to send 100% duty cycle, you will send 255. It will be 100%. If you send 127 here, it will be 50% duty cycle. And if you send 76%, it will be 30% duty cycle. And 50% means half the speed of motor or half the brightness of an LED, and 30% means 1/3. So approximately 1/3. For example, to send 70% duty cycle to pin 3, then what should you do? What should the value be? In that case, we would use 70, that we want 70% duty cycle times 20 times 25 divided by 100, and the answer will be 178. So we will write digital write 178, comma 3, because we intended to use pin 3. And 178 will send 70% duty cycle signal to pin 3. So only the pins that are marked with this tilde are pulse width modulation enabled pins. Not all pins are pulse width modulation enabled. And in Arduino Uno, pin 3, 5, 6, 9, 10 and 11 are pulse width modulation enabled pins. And here I have zoomed in so you can see it. Pin 3 is pulse width modulation, 5, 6, 9, 10 and 11. If you try to use any other pins, you will not get the result. Now this is our first lesson. We have an LED that is, the cathode is connected to ground, and from the anode we have a 220 ohm or 330 ohm resistor connected to pin 9 in this example. And here is the wiring from the longer pin, which is connected to a breadboard. We have a resistor connected to the other side, this area, the divider, and from here we have a blue wire connected to pin 9. And from the left wire we have a black wire from the ground. A black wire is connected to ground, and that's the wiring. And here exactly the same way that you saw in the diagram. The longer pin is connected to this side. From the longer pin we have 220 ohm resistor. If I bend it, you can see it. It has come to this point, and from here we have a blue wire connected to pin 3 in this case. Whatever pin you define, in our code, in the screen it was 9, so it is connected to pin 9. And from the negative we have a black wire connected to ground. So this was the wiring. Here is the code for controlling basic LED. We define a variable called LED pin, and we set the value to 9 or assign 9 to this variable. And after that, inside the setup, we use pin mode LED pin as output. So this is defining pin as an output. And in the next line we use digital write and LED pin, and we send 50. So that 50 is like 1/5 of 250, so the LED will turn on when we keep it waiting for 5 seconds. And after that we use again digital write, and this time we send 0. So this 0 means turn off the LED and keep it off for half a second, 500 milliseconds, and then we use digital write. This time we send 255. That's the maximum. LED will turn on with 100% and wait for 5 seconds, and then we turn it off and wait for half a second, and this time we send 100, and it will stay like that, because inside the loop we don't have anything. The LED will stay on like that. Arduino is connected. This is our code, COM4. Let's upload the code. So pay attention that this will be a little dim initially, yes, and it will increase after 5 seconds. It will turn off and get brightened, and after that turns off and it will be dimmer. Let me turn the light off so you can see it maybe from this side better. Now to restart it, I'm pressing this reset button. The program will restart again. So that's very dim. After 5 seconds it will go maximum, and then after 5 seconds it will go dimmer. So this is the code that we had here. In this example we are going to fade the LED from 0 to 255. So we will increase the brightness of LED using something called for loop. The for loop has an opening parenthesis and closing, and it has semicolon, and it has 3 value or 3 arguments between the semicolons. The first one is called initialization, comparison, and increment. Here we initialize integer variable called value with 0, and here we compare if value is smaller than 255 or equal. This means smaller and that means equal. Then we come here and print it. So 0 will be printed digital write LED pin, which is whatever pin we have, let's say 3 or 9, and the value, which is 0, will be printed. After this, it goes here, 0 plus 5, it becomes, the value becomes 5, because value plus 5 means, this means get the value and add 5 to it. So now this becomes 5. We come here, 5 is smaller. Is 5 smaller than 255? Yes. Print this. So now we will print 5. So LED will turn on a little. That goes back here. Now it becomes 10. Compare. True is 10 smaller than 255? True. Print 10, and it will be more brighter, and it comes back. 15. Compare, print, and 20. Compare, print, and 25, 30, 35, 40, up to 255. Now 255 is the maximum brightness, the LED is the maximum brightness, then it comes here, 255 plus 5 is 260, so the value is now 260. Is 260 smaller than 255? No. Exit. So the loop will exit, and the LED will stay with the maximum brightness, and this loop doesn't do anything else. Now, to understand it better, I made this smaller number so we can see in all steps. We initialize the I, which is 0. So this is initial values. And after that, we compare if 0 is smaller than 4, true. Then we print 0. So 0 is printed on the serial monitor. After that, we go. This is called increment. I plus plus means get I and add 1 to it. So this is called increment. In this case, now I is 1, becomes 1. And then we come here and compare. Is 1 smaller than 4? True. Come here and print 1. Then we come to this point and increment it. It becomes 2. Is 2 smaller than 4? True. And then print 2. Now go here, increment. I is 3. Compare, is 3 smaller than 4? True. Print. Done. Come here, increment it, make it 4. So I is 4. Is 4 smaller than 4? No. Exit. So this is how for loop works. Pay attention that this is the area where we circle. We compare, increment, and execute. So compare, execute, increment. Compare, execute, increment. Between two parentheses, we can have as many lines of code as we want. We can write it. Everything will be executed. But this portion will be just at the beginning. Only once we initialize and compare. Then we will never come back to this point. Now let me explain this code. We have defined here pin 3. Let me change it to pin 9 so we don't change our wiring. And inside the setup, we define LED pin as output. Inside the loop, we have the for loop. We initialize the value variable as 0, and we say if value is smaller than 255, comma, and then this semicolon, and then we say value incremented with 5. And after that, digital write, we write to this pin, digital write, LED pin, and then the value 0. And then we keep it waiting for 50 milliseconds. I have added this so we can see it. Otherwise, it will go very quick and you will not even notice it. So 50 milliseconds, and it comes back. It becomes 10, 15, 20, 25, 30, and up to 255, and which is the maximum. And the loop will exit, and it will have 1 second delay. Because we have another loop here, after this, it comes back, and it starts with 0. So the LED will fade and to the maximum, and 1 second delay at the maximum, and then turn off. this will continue forever like that. Now the wiring is exactly the same. Let me just upload the code. You will see it. So you see now it's fading. After a certain point you will not even notice it, because so it is fading from minimum to maximum and staying like that. Maybe now you could see it better. We have another type of loop also called while loop. Let's see how it functions. So what while loop is a type of loop which executes a block of code until certain condition is met. And when the condition is met, the loop exits. Here is the code for the while loop. We have defined B with a value of 4. Serial monitor is initialized with 9600 baud, and while loop does the same thing: compare, decrement, and print. We don't go inside the loop, so this will just print B. Now let me upload the code. Now this doesn't do anything, but I'm going to use this reset so you can see it. Let's open the serial monitor. As you can see, it printed 321 in here, but if I press reset, you will see it will do it again. 3210. 3210. And here example 2, we say integer b is equal 0. In this case, we compare. Is b smaller than 4? True. Then print 0. Now increment. B is 1. Now from here we go back, compare. Is 1 smaller than 4? True. Print. So print 1. Increment. B is 2 now. Come back, compare. Is 2 smaller than 4? True. Then print 2. Come here, increment, it becomes 3. Compare, is 3 smaller than 4? True. Print 3. Increment 4. So now B is 4. Compare, is 4 smaller than 4? False. Exit. So this was with the increment. Before was with the decrement. Here is the other example where we increment. B is now defined with 0, and here we check if B is smaller than 4. Print it, increment it, and then B become 1, 2, 3, and 4 will not be printed. Let me upload the code. The code is uploaded. Let's click and open serial monitor. So you see 0, 1, 2, 3. Before it was 3, 2, 1, 0. This is now printing it in reverse. So you see the whole code, and here let me just reset it. 0, 1, 2, 3. And one more time. So we have another type of while called do while. It's similar, but the structure is different. So we initialize integer b with 4, and then here we say do, and then opening and curly braces, and here we have while, and the condition is below, not at the top. So we have two things. We have b, do, and condition. Now let's see here. B is 4, and we are decrementing it, so we are printing b. We have b equal 3, and this is printing 3. This line. Now we compare here. Is b smaller than 0? True. correct? Now we go here, decrement, it makes it 2. Come here and print, now 2. Compare, is 2 smaller, bigger than 0? True. Correct? Go back, decrement and make it 1. Print it. This line was printing it as 1. Then we come here, is 1 greater than 0? True. So decrement, make it 0. Print 0. Come here, is 0 greater than 0? False. Not true. Exit. So this loop will exit. This is the code for do and while. We have defined b equal 4. Initialize the serial monitor with 9600. We say do, subtract, print, and compare as I have explained. Let me upload the code. So let me open the serial monitor. So it printed do, subtract, as you can see, 3210, and when b is 0, it's not great, it will exit. Let me reset it by pressing this button. So the code is now printing again. If I press it again, it will do it again.